More than 3,000 years ago, a giant volcanic eruption buried the city of Akrotiri on the ancient island of Thera, now known as Santorini.
Beneath the dazzling blue waters of the Aegean lies something far more dangerous than anyone imagined, an ancient force, still alive, still waiting. Santorini, known for its postcard-perfect cliffs and whitewashed villages.
Over 500 earthquakes have struck Santorini in just a few days. At this point, most of them are small, but they are intensifying.
Hides a volcanic history so explosive that it reshaped entire civilizations.
The Greek island of Santorini sits on top of a volcano. The last major eruptions occurred in 1950.
Scientists have uncovered new evidence suggesting that beneath this legendary supervolcano, another, even more mysterious volcanic structure may be stirring.
After several days of near-constant earthquakes hitting the island, perched on the rim of an ancient volcano, residents are fleeing in droves.
Could this hidden powerhouse be reawakening? Could history repeat itself in ways more terrifying than we ever thought possible? The clues are everywhere, but the truth is only beginning to emerge. Stay with us as we dive into the untold story of Santorini, where myth, science, and raw geological power collide in a way that could change everything we know. Santorini's hidden volcanic threat. Beneath the stunning blue waters of the Aegean Sea, Santorini holds a geological secret that has fascinated scientists for decades. A volcano within a supervolcano. While many are aware of Santorini's massive volcanic history, recent studies suggest that a smaller, active volcanic structure is hidden deep within its massive caldera. Advanced imaging techniques and seismic monitoring have revealed a network of magma chambers and vents beneath the island, indicating that Santorini's volcanic system is far more complex than previously thought. This discovery has intensified concerns among geologists, as even minor shifts in underground magma movement could trigger future eruptions, posing a potential risk to the region. The caldera of Santorini, as we see it today, is said to be the result of much volcanic activity over hundreds of thousands of years, with the corresponding development of the island through a series of eruptions and collapses, each adding to the layered style of its geological structure. Of all, the most renowned event is the Minoan eruption some 3,600 years ago, which, amongst the largest volcanic disasters ever in recorded history, decimated ancient civilizations while sending tsunami walls crashing across the eastern Mediterranean. But what many do not know is that the Santorini volcanic system never fell quiet after such a disastrous eruption. Instead, it stayed active, and contemporary formations like Nea Kameni and Palea Kameni have risen from the caldera over the past century under continuous magmatic activity. Up to this day, studies in modern geophysical surveys indicate that the internal working of Santorini's volcanic system shows that magma reservoirs are moving, changing shape, and mingling with the rocks surrounding it. Seismic tomography, with increased resolution, shows that this area intermittently injects magma. This may cause ground swelling and set conditions for future eruptions. Recent increases in seismic events and hydrothermal emissions have raised alarms and prompted scientists and local authorities to take precautionary action in monitoring. Evidence suggests that Santorini has huge geological activities even underneath the astonishing surface, aside from being a very quiet place. While nested volcanoes are not only a serious scientific curiosity, but also the future behavior of the long-term volcanic island itself. A whole world of deep magma chambers, as well as tectonic stresses and past collapse events, will prove that indeed, Santorini is not the most stable of volcanic systems. All the same, this pressure will insist on better strategies being developed for hazard mitigation in the region as new data surfaces and models for prediction improve. But under this beauty lies a seething force sleeping, waiting to wake up once again and remind the world of its explosive past. Very few places in the world have such force with the beauty of Santorini in contrast. But Santorini's volcanic secrets don't just end with hidden magma chambers. Let's keep going. The Minoan eruption. Around 1600 BC, the Minoan eruption of Santorini unleashed one of the most devastating volcanic disasters in human history, forever altering the ancient world. This catastrophic explosion, estimated to have expelled between 30 and 60 cubic kilometers of magma, was so powerful that it reshaped the entire geography of the region. Towering ash clouds darkened the skies, reaching into the stratosphere, while pyroclastic flows and immense amounts of volcanic debris buried everything in their path. The eruption's force caused the center of the island to collapse, forming the vast caldera that defines Santorini's landscape today. Although no direct records from the time exist, later accounts interwoven with myths and legends suggest that the event left an indelible mark on civilizations across the Mediterranean. The most immediate and devastating consequences of the eruption were felt by the Minoan civilization, which had flourished on the nearby island of Crete. As the eruption sent enormous tsunamis racing across the sea, coastal settlements were obliterated, infrastructure was destroyed, and agricultural lands were rendered infertile due to layers of volcanic ash. The disaster disrupted trade routes and economic stability, which were vital to the Minoans' dominance in the region. Though Crete's civilization did not collapse overnight, evidence suggests that the weakening of the Minoan society made it vulnerable to later invasions, particularly from the Mycenaeans. Some historians even argue that the event played a pivotal role in the eventual decline of the Minoan Empire, one of the most sophisticated societies of the ancient world. Besides the initial disintegration, the Minoan eruption left long-term climatic effects extending far beyond the Aegean. Modern-day climate models and studies of volcanic ash and sulfur deposits suggest that this eruption was the initiator of a short-term global-scale cooling. The vast quantities of sulfur dioxide released into the atmosphere would have created a volcanic winter, reducing temperatures and disrupting weather patterns across the globe. Such changes in the environment may have led to failed harvests, famine, and severe social upheavals thousands of miles away, such as in Egypt and Mesopotamia. It has been this link between volcanic activity and historical change that has brought forth further examination into the effects of large-scale eruptions on things human. The legacy of the Minoan eruption can still be seen in Santorini's geology, myths, and current scientific research that evolves gradually. The immediate and violent destruction of a prosperous society has further sparked speculation, connecting the calamity to the myth of Atlantis, a civilization presumed to have been swallowed by the sea. Meanwhile, modern investigations using seismic imaging and geochemical analyses continue to uncover new aspects concerning this event, providing very valuable information on the force of volcanic activity and the extent to which they can make history. History remembers Santorini as a place where nature changed civilization. Scientists continue to observe the region in anticipation of future disturbances, still too aware of the precedent built by the Minoan eruption. Science behind Santorini's volcanic evolution. Santorini's dramatic landscape is the result of millions of years of volcanic activity driven by powerful tectonic forces beneath the Aegean Sea. The island is part of the Hellenic volcanic arc, a region shaped by the ongoing subduction of the African tectonic plate beneath the Aegean Sea plate. As the African plate slowly descends, immense pressure forces molten rock upward, forming vast underground magma chambers that serve as the reservoirs for periodic eruptions. Over hundreds of thousands of years, these eruptions have deposited layers of basaltic lava, pumice, and volcanic ash, gradually building the archipelago that exists today. This long and complex history of volcanic activity has resulted in the formation of Santorini's iconic caldera, a massive, submerged crater that tells the story of multiple cycles of eruption and collapse. Recent scientific investigations using high-resolution seismic tomography and deep penetration radar have provided unprecedented insight into Santorini's internal structure. These advanced imaging techniques reveal that the island's volcanic system is far from a single, monolithic structure. Rather, it is a network of interconnected magma chambers and volcanic vents. The present-day caldera which stretches approximately 12 kilometers in length and 7 kilometers in width, is the result of repeated collapses following major eruptions. Radiometric dating of volcanic deposits suggests that this process has been ongoing for at least 500,000 years, with each major eruption reshaping the island's topography. By analyzing the chemical composition of these volcanic layers, researchers have been able to trace the evolution of Santorini's magma system, from early basaltic flows to later silica-rich, explosive eruptions. The evolution of Santorini is fascinating. Traditionally, volcanic diminutive had hardly extraordinary eruptions, while now, the cataclysmically explosive eruptions stamp the very history of the island. This switch in character of the eruptions has been associated with an evolution in phase composition over time. Research on material from drill core samples and volcanic ashes indicates that during the onset of the eruptions, basaltic magmas with low viscosity flowed more or less and were, therefore, less explosive. The eruptions changed as the magma chamber matured, producing magma with a high content of silica. The lava thickened, became more vesiculated, and therefore violent. At the very end of that evolution was the Minoan eruption, one of the most explosive events in recorded human history, occurring soon thereafter, in which vast amounts of ash and pumice were expelled within days. Such transitions in magma provide essential tools for scientists to check the future volcanic activity of the island. Santorini is an active volcanic system whose processes are implanting their imprint in the island's future. Subsequently, monitoring activities of ash venting and seismicity have undergone probing for the magma injections within the caldera. The evidence so far for its activity is the birth and development of the new volcanic islands, Nea Kameni and Palea Kameni, in the last few centuries. Scientists are tracking small-scale changes in Santorini's magma chamber systems using satellite imaging, ground deformation, and gas emissions. These scientists wish to contribute to advancing volcanic hazard modeling and its early warning system by understanding these processes, thus providing a more profound knowledge of nested volcanism like that of Santorini. Learning from the past of Santorini would greatly benefit its own future and the global understanding of volcanoes. Geophysical discoveries. Santorini's breathtaking cliffs and submerged caldera are just the surface expressions of a far more complex and dynamic geological system hidden beneath the Aegean Sea. Recent geophysical surveys have provided scientists with groundbreaking insights into the island's volcanic structure, revealing a vast and interconnected network of magma chambers, fault lines, and hydrothermal vents. High-resolution seismic tomography and deep-penetration radar have mapped the internal architecture of Santorini's volcanic system, confirming that its formation was not a single event, but rather a continuous process of construction and collapse spanning hundreds of thousands of years. These studies have also shown that Santorini is not just one volcano, but a multi-layered structure formed by repeated episodes of eruption and subsidence, with magma reservoirs buried deep beneath the seafloor. One of the most significant discoveries in recent years is the evidence of active magma movement beneath Santorini's caldera. Seismographs and satellite-based ground deformation studies have detected signs of magma injections at depths of several kilometers, indicating that the volcanic system remains active. These magma pulses cause the ground to swell, creating subtle but measurable shifts in elevation that scientists carefully monitor. Additionally, geophysical surveys have uncovered the presence of hidden fault lines running beneath the island, which play a crucial role in controlling the flow of magma. The interplay between these faults and Santorini's magma chambers suggests that tectonic stress and volcanic activity are closely linked, making it even more challenging to predict future eruptions with certainty. In a further key finding from deep-sea research at Santorini's submerged caldera, researchers discovered hydrothermal vents spewing superheated gases and solid materials into the ocean. These vents are aligned with fractures in the volcanic rock and signify the fact that major geothermal activity still occurs under the ocean floor. Such chemical analyses, via the gases emitted from these vents, show high contents of sulfur dioxide and carbon dioxide, clear indicators of an active magmatic system. Such emissions suggest that magma is still undertaking interactions with seawater, a process that can contribute to explosive underwater eruptions. The geological features revealed by such hydrothermal vents highlight that the volcano of Santorini is not dormant, but is in a phase of activity, even if slow. These include the physical discovery of Santorini's volcanic system, rich in complexity and constant change. Indeed, there may be little volcanic activity in the last few centuries. However, all the evidence collected through seismic monitoring, satellite imaging, and undersea research indicates that the magmatic system of the island is still undergoing development. The discovery of new magma pathways and structural weaknesses of the caldera has encouraged scientists and local authorities to continue monitoring efforts, guaranteeing the early detection of renewed volcanic activity. While continuously delving deeper under the surface, the countdown to the unraveling of Santorini's exploding past continues with every new finding from researchers. A geological mystery. The Minoan Ring Island is one of Santorini's most intriguing geological formations, offering a glimpse into the island's explosive past and ongoing volcanic evolution. Formed after the massive Minoan eruption around 1600 BC, this ring-shaped caldera remnant is believed to be the result of a catastrophic collapse when the volcano's primary magma chamber was emptied. As the overlying landmass lost its structural support, it caved in, creating a circular depression that was later partially filled by volcanic activity and seawater. Today, the remains of this ancient structure continue to captivate scientists, who are using advanced imaging techniques to uncover new details about its formation and significance. Petrographic investigations and radar deep penetration studies earlier revealed that this island is the result of a complex volcanic history, rendered ignimbritic, basaltic, and rhyolitic. These indicate a series of explosive eruptions alternated with slow rebuilding. The chemical evolution of these deposits seems to suggest that the underlying Santorini volcanic system has changed dramatically over time, from earlier basaltic eruptions to later higher silica explosive events. Research on stratigraphy in Minoan Ring Island would bring much value to studies focusing on magma compositions and volcanic activity over several 100,000 of years. The most exciting findings related to the Minoan Ring Island are the repeated indications of collapse events. According to core sample drilling and ash layer analysis, the caldera is not considered by many to be a result of a single such event. Rather, it developed slowly over the centuries. It is a major feature by which one can think of Santorini's volcanic evolution. The innermost nested caldera is built by the continuous and very dynamic volcanic activity of Santorini. This is very important in understanding the long-term caldera-forming eruption behavior and risk of eruption. The Minoan Ring Island has all the geological aspects of being a part of the jigsaw pieces connecting the old eruptions in Santorini to the future of humans and their climate. According to studies, the Minoan eruption that shaped this ring structure was a cause of disruption in the climatic systems around the globe, mostly by short-term cooling effects and also by the ruin of regional agricultural production. Research on how this eruption has impacted humanity by destroying Minoan society on Crete is continuing. Somewhere, in the time to come, there lie unexplored enigmas about the eruptions of Santorini, which will be brought to as yet unrevealed in Minoan Ring Island with further research. Santorini's fiery past left more than just geological scars. Its eruptions sent shockwaves into the atmosphere, setting off a chain reaction that would disrupt weather patterns and reshape climates across the globe. How volcanic eruptions impact climate change. Volcanic eruptions have long been recognized as major contributors to climate change, both in the short and long term. Santorini's catastrophic Minoan eruption around 1600 BC serves as a prime example of how a single volcanic event can disrupt global weather patterns. When the eruption occurred, it expelled massive amounts of volcanic ash, gases, and sulfur dioxide into the atmosphere. These fine particles and gases were carried into the stratosphere, where they formed reflective aerosols that blocked sunlight, leading to a temporary cooling effect. Scientific studies of sulfur aerosol deposits linked to the Minoan eruption suggest that global temperatures dropped significantly in the aftermath, disrupting agricultural cycles and settlement patterns across the Mediterranean and beyond. The immediate climatic impact of volcanic eruptions is largely driven by the release of sulfur dioxide, SO2, which reacts with water vapor in the atmosphere to form sulfate aerosols. These aerosols create a reflective layer that reduces the amount of solar radiation reaching the Earth's surface, resulting in a phenomenon known as volcanic winter. Similar events in more recent history, such as the eruption of Mount Tambora in 1815, caused severe climate anomalies, leading to the infamous year without a summer, when crop failures and food shortages were reported worldwide. In the case of Santorini, the cooling effect, though not as well documented, is believed to have played a role in altering regional weather patterns, contributing to social and economic instability in ancient civilizations. Volcanic eruptions can bring about climate disturbances and have longer-lasting effects that can either cool or warm the planet due to the introduction of gases to the atmosphere, especially CO2. The CO2 emissions from any one eruption may be negligible on a global scale compared to anthropogenic emissions, yet throughout thousands or millions of years, sustained volcanic activity could very well account for an interval of global warming. In the case of Santorini, the eruptions have introduced varying concentrations of oceanic chemicals and atmospheric conditions that can disturb the delicate balance of Earth's climatic system. Even today, scientists are investigating how past volcanism, including eruptions at Santorini, may develop lessons concerning trends in climate change that we should watch for in the future, especially given the rising concern for environmental issues. The study of volcanic eruptions like that of Santorini during the Minoan time has great implications for modern climate science. With the help of ash and sulfur layers in ice cores and ocean sediments, scientists can reconstruct a viable image of ancient climate changes and assess the interplay between volcanism and atmospheric perturbations. These are relevant to calibrating climate models and predicting future impacts of eruptions on global temperature. Current volcanic activity around the world, especially that from the still active Santorini system, means that scientists will always remain on the lookout for the impacts of volcanism on the shaping of our landscape and climate. Santorini's modern volcanic activity. Although Santorini's last major eruption occurred in 1950, recent scientific data suggests that the island's volcanic system remains active and evolving. Modern monitoring techniques, including seismic imaging, satellite-based ground deformation analysis, and geochemical surveys, have detected signs of magma movement beneath the caldera. Increased seismic tremors, hydrothermal vent activity, and subtle swelling of the ground indicate that the magma chambers beneath Santorini are not dormant. While these signals do not necessarily mean an eruption is imminent, they confirm that the volcanic system is still dynamic and requires continuous monitoring. Given Santorini's history of explosive eruptions, scientists are carefully analyzing these signs to better predict potential future activity. The birth of two volcanic islands sitting within the caldera, Nea Kameni and Palea Kameni, and their gradual growth are two of the most crucial markers of active volcanism in Santorini. During past eruptions, these islands had been formed subsequent to a period of continuing geological, geothermal, and magmatic activity. Sporadic eruptions have continued to be identified by the scientific community, along with temperature variations. Hydrothermal vents surrounding these islands effuse hot gases, including sulfur dioxide, providing useful evidence that some magma is interacting with underground water. These active vents and subtle geological activity occurring within the caldera have maintained the theory that Santorini's volcanic cycle is far from completion. The question being posed to researchers today involves the eventual fate of these processes regarding eruptive activity, either by slow, effusive lava flows or more explosive eruptions. With an aim to secure the safety of residents and the millions of tourists who visit Santorini every year, The monitoring efforts have been doubled by local authorities and research institutions. Any movement on the island's volcanic system is being recorded by means of a network of seismographs, satellite observations, and deep penetration radar studies. Emergency response plans, hazard maps for the island, and different educational campaigns prepare the local community for possible eruptions. When the next explosive eruption indeed will happen remains unknown. Although these monitoring efforts in Santorini are crucial for understanding and minimizing the dangers of living in an active caldera, beneath all this hair-raising beauty lies geology, and indeed geologic restlessness, for forces exist that can certainly affect the future of these islands. The myth. Santorini's catastrophic volcanic history has inspired myths and legends for centuries, blending ancient storytelling with geological realities. One of the most famous theories links the Minoan eruption around 1600 BC to the legend of Atlantis, the lost civilization described by the Greek philosopher Plato. According to the myth, Atlantis was an advanced society that was suddenly swallowed by the sea after a series of catastrophic events. The massive eruption of Santorini, which caused the central part of the island to collapse into the caldera, bears striking similarities to this story. While there is no definitive proof that Santorini was the real Atlantis, the parallels between the eruption's devastation and the myth's themes of destruction continue to intrigue researchers and historians alike. Ancient Greek myths sometimes feature the devastating eruption of Santorini, which Hephaestus, god of fire and volcanoes, allegedly created as he fashioned weapons deep in the earth. Such terrifying from the birth fiery madness resulted. Others put the thrust of the island to Poseidon, god of the sea, who could make giant earthquakes and waves just like that other big tsunami that was said to have come after the Minoan eruption. Those gods were indeed furious. These are all among the first historical attempts to explain the sudden and violent natural forces at work on this land. Thus, mythologists told stories about such disasters, while scientists unveiled the geological nature of the anger of Santorini. Now, modern scientists have some high-tech instruments to probe into volcanic activity that has been mythologized. They have tried seismic imaging, geochemical analysis, and even deep-sea surveying for evidence of the huge Minoan eruption that took its toll not only on Cretan terrain, but Cretan climates. Layers of ash from eruptions spread over Aegean coasts, and tsunamis testify about the distant effects of the event, thus supporting the hypothesis that perhaps it contributed to the fall of the Minoan civilization in Crete. Hence, Santorini becomes a glorious gap through which mythological and scientific revelation meet, based on actual disasters preserved into ancient lore, and thus assisting future understanding by modern scientists of those very forces that today are shaping Earth. Living laboratory for volcanic research. Santorini's unique geological history makes it one of the most important sites for volcanic research in the world. The island, which was formed through a series of explosive eruptions and caldera collapses, provides scientists with a rare opportunity to study an active volcanic system that has been evolving for hundreds of thousands of years. Advanced monitoring tools, such as seismic imaging, satellite-based deformation analysis, and geochemical sampling, allow researchers to track ongoing magma movement beneath the caldera. By studying the interactions between deep-seated magma chambers and surface tectonics, scientists can refine their understanding of how nested volcanic systems like Santorini behave and potentially predict future eruptions with greater accuracy. Another key consideration to address when investigating Santorini's importance in research is the development of magma-water tectonism interaction understanding. The submerged caldera and hydrothermal vents of the island provide insight into how volcanic systems work under marine conditions. Nowadays, scientists have come to understand that the movements of magma beneath the seafloor might be responsible for the release of hot gases and mineral-rich fluids, contributing to chemical and thermal modification of the surrounding water. Their interaction with seawater is of core importance to understanding the functioning of submarine volcanoes in terms of explosive eruptions. Thus, Santorini's ambience allows consideration of land and water volcanism more broadly sketched in geological terms. On the other hand, Santorini's research, which goes beyond volcanology, provides key insights into hazard mitigation and climate science. The catastrophic eruptions in the island history, particularly the massive Minoan eruption, serve as the case study for volcanic activities affecting climate, people's civilizational existence, and the ecosystems of the region. Volcanic deposits on land and gas emissions in the atmosphere are studied by scientists to unravel the past environmental changes, which has implications for the present and future behavior of volcanic activities anywhere else across the globe. Research on Santorini, therefore, helps safeguard the safety of its residents and tourists, and continues to build knowledge onto the wider understanding of dynamic forces operating on Earth, lending further credence to the argument for continued study of areas of active volcanism. Studying Santorini's restless volcanic system isn't just about uncovering its past. It's a race to understand its future and ensure that, when the Earth stirs again, we're ready. Volcanic risk and disaster. Management. As Santorini remains an active volcanic system, scientists and local authorities have prioritized continuous monitoring and disaster preparedness to mitigate potential risks. Advanced volcanic monitoring systems, including seismic networks, satellite imaging, and ground deformation sensors, provide real-time data on magma movement and tectonic activity beneath the island. These tools help detect early warning signs such as increased seismic tremors, hydrothermal emissions, and ground swelling, which could indicate an impending eruption. Given the island's history of catastrophic eruptions, researchers are working closely with international geological organizations to refine predictive models and improve hazard assessment techniques. By staying ahead of potential volcanic threats, authorities can implement timely response measures to protect both residents and the millions of tourists who visit Santorini each year. Other than scientific observations, disaster management relies on emergency response measures and general preparedness. The local authorities drew up comprehensive evacuation plans and hazard maps that indicate high-risk areas and safe evacuation routes in case of an eruption. Public advocacy is a key element in informing residents and tourists about volcanic hazards and emergency protocols. Drilling and coordination with foreign experts as to disaster response are outlets through which Santorini prepares for emergencies. While the tourism industry is a significant part of Santorini's income, it makes for a difficult balance when weighing safety measures and everyday life. In this vein, the challenge seems to be to improve vigilance and prevent panic while allowing visitors and locals to coexist with the volcanic landscape, and prevent panic while allowing visitors and locals to coexist with the volcanic landscape. The Santorini model of volcanic disaster risk management serves as a guide for other active caldera regions. Geological research is an essential component in safety measures, as demonstrated by cooperation among scientists, policymakers, and emergency management teams. The preparedness lessons drawn from the Santorini experience are of great importance to other communities grappling with similar threats caused by the influence of climate change and tectonic movements leading to volcanic activity worldwide. While it may never be possible to predict appropriately how or when the next eruption will develop, preparedness runs a bit through the actions of research and planning. Thus, Santorini is as well prepared as it can possibly be for any outcome arising from future volcanic activities. Thanks for joining me on this deep dive into Santorini's explosive past, but there's still so much more to learn. If you found this fascinating, don't forget to like this video, subscribe for more mind-blowing explorations, and hit the notification bell so you never miss an update. Do you have thoughts or theories? Drop them in the comments below. I'd love to hear what you think. And if you're curious about more earth-shaking mysteries, click on the next video on your screen right now. Trust me, you won't want to miss it. Stay curious, keep exploring, and I'll see you in the next adventure.